Two particles with the same charge and the same initial velocity enter the mass selector of a mass spectrometer. Particle A has twice the mass of particle B. If particle A lands 0.5 meters away on the detector screen, where does particle B land? All right, well, let's start at the beginning with Newton's second law. So we have F equals ma. The only force acting here, we're assuming gravity is negligible. The only force is qvb. And the acceleration is centripetal. And we're going to solve this for r. So we're dividing both sides by v. And we're going to multiply r to this side. And then we're going to divide both sides by qb. And we see that r is equal to mv over qb. Now the only things that are different between particles A and B are their mass. So we don't even have to worry about these things right now. We see that those are directly proportional. So if particle A has twice the mass, so particle B is going to have half the mass, which means it will have half the radius. So if we plug in m over 2 in here, we're going to get r over 2. So right now, the diameter of the orbit is 0.5, which means the radius is 0.25. But we don't actually have to convert it to radius or diameter, because if the radius is cut in half, the diameter is also cut in half, which means particle B is going to land halfway, so 0.25 meters. It will have half the radius, it will have half the diameter. The answer is